Mike Fogg is going to present about FIREfly, which is a scientific data server for acquiring and analyzing data.
Okay, I'm here. Can you see my screen?
Yes, please go ahead.
Okay, great. Okay, yeah, we are a little over time, so I'll try to make this more of a lightning talk to try to do what I can to help catch up. So I'm going to talk about a project that was a joint project between the HDF group and a company called Acadio that was kind of a spin-off and was interested in doing some more things in the commercial sector. This was an SBIR, Small Business Innovative Research project funded by the Air Force. And it's a phase 1 project. It was a building of a prototype, and we called it FIREfly. And it was for flight test data and to use HSDS. Let's see. Oh, here we go. If we think about the life cycle of test data, you know, there's a test preparation, then the running, then the analysis, quick analysis right during or right after the test, and then a more in-depth analysis, and then long-term analysis. And I'll skip a couple of slides down here to speed things up. But basically, you've got data at each of these stages, and that accumulates as you go from left to right. And when you get to the point of the in-depth analysis, you have all of the data from the test run, which is where the massive amounts. In the case of flight testing, it's typically in a format called Chapter 10. It's at least very common to do that, especially in the Air Force, but in other places as well. You can have several terabytes of data. And then you have data products that get built and so forth. And also, as you move from right to left, you have more people involved. So you have people doing data analysis. In the case of the Air Force, you might have tests running on the same aircraft at several different locations in the country, at different air bases. And of course, it's not just one test at each place, but you know, every place you have lots of tests, maybe tens or dozens or even hundreds, maybe of the same aircraft or the same device on the aircraft or whatever. And there's often the analysis part. The analysts will need to share the data among these different places where the tests occur. But typically right now, each location has its own repository for its own data. And so this creates quite a few headaches. First of all, the time that it takes to find the data or to move the data from one place to another. You get a lot of data replication. You can get a lot of confusion about whether, you know, one replication of some data is actually the same data that you started with. So this can be very expensive and time consuming, and it's a challenge. And the way that the Air Force put it in their call for proposals was to say much of this data resides in repositories that are isolated from each other. They have limited search and computing capabilities and varying depending on the location. And it's hard to access data, you know, between them, which in turn makes data discovery difficult, slows down the data analysis component, impedes the sharing of results, and can constrain the large-scale data analysis. Did I? I guess I'm not showing myself here, am I? I'm sorry about that. I'll start up my video here so you can see who's talking. So that was the current state, and so they asked if you know, people would propose to develop a data server, had to be open source and web-based, and provide various capabilities, the ability to ingest data into this server, perform queries, to do data analysis and visualization, and be able to actually move subsets of the data from one place to another, and also be able to upload algorithms to the server to be performed on the server side. They wanted this to be hosted in a cloud environment, ideally both a public cloud and also an on-prem cloud. And there was one other, not necessarily requirements, but something that they asked for, and they asked if solutions might address these issues using HSDS. Why would they have thought about HSDS? Well, it turns out that a lot of flight test data has been stored in HDF5 going back to the early 2000s. To my knowledge, Boeing was the first company to adopt HDF5 as a way of organizing flight test data. Typically, as I said, the flight test data during the test goes into a packet-based format called Chapter 10, but then it's not unusual once the test is finished to convert that into HDF5, where it's much more manageable and much easier to do the kinds of operations that they need to do in the analysis stage of the data. So we proposed to do a server based on HSDS that would, first of all, take in Chapter 10 data. So take in the raw flight test data, pull out certain parameters and convert them to engineering units and store them in HDF5. Allow the user, if they wanted to go in and to get other parameters, to do that with the other parameters as well, with other parameters. Typically, a flight test might have 1,000 or multiple thousands of different instruments, so different readings, different parameters, and usually an analyst doesn't want more than maybe just a dozen or so, or even fewer than that in the analysis. So it doesn't make sense to convert everything. So that was what we proposed. Our team consisted of, Garrett Haber was the guy who came up with the concept for the original architectural concept, working with John. But once the project started, John Reedy and Alexander Jelinek were the primary guys who did the implementation. I was the project manager. We worked with a guy named Bob Baggerman, and he was absolutely critical to the project. It was a linchpin. He provided some software, but more importantly, he just provided advice and connections and so forth. Another team member was Chris Colbert of SEC Software, who did a GUI interface for us. Our contact in the Air Force was a guy named Jeff Korn, and he gave us a tremendous amount of good advice, as well as introducing us to other Air Force folks who could help steer the development of the project. So what we proposed was a data server with 4 core functions that we called ingest, for ingesting the data into the server; filter, that would allow a user to do queries on the data to find the data that they were interested in; reduce, for the data reduction component, which would be like visualization and the analysis side; and then the extract for actually pulling data off of the server, downloading it onto the client side in formats that might be more convenient for the client. If we rearrange those 4 words, we get FIRE, and that's where FIREfly, the name of the project, came from. This is a kind of a schematic of the overall architecture. Down in the lower left, we see a Chapter 10 archive. Chapter 10 files would arrive at this archive, and John implemented a watchdog container that would discover whenever a file arrived, and then would spawn a process that would convert that file into HDF5 and create some metadata and store it in the server. On the analyst side, we had a Jupyter Hub interface. So that was a familiar interface. And Alexander implemented routines that would allow them to do querying, as well as the reduction or analysis. And of course, the analyst could, since they were working in a Python, we did this in primarily focused on the Python. but of course it could be extended to other languages as well. The analysts could create their own data analysis routines within that. And so all of that communicated with the HSDS server, where the Python code would be executed using the HDF5 object store for the data that John described earlier. And then the extraction component would allow the same analyst to request data, and this would spawn a process that would convert the data to HDF5 or CSV formats, and of course other formats could be supported in the future. So that's that kind of describes it. We used a number of open source components: HSDS, Jupyter Lab, Docker, and Kubernetes. And then I mentioned Bob Baggerman, who had already created a Python package for extracting and converting Chapter 10 data. We had to develop some other packages for the project. Alexander implemented something called FIREfly Py, which is a Python package that supports the data query analysis and visualization. We did one extension to Bob's Pi 106 package by adding the video capabilities, video data extraction capabilities. John added some query enhancements to HSDS. I mentioned that Stephen Colbert did the GUI query implementation, and then the watchdogs and the converters. And then we also discovered when we started the project that we wanted some sample data, and the Air Force was able to make available to us 3 Chapter 10 files. Well, that wasn't so great if we were trying to achieve scalability. So we were able to create a synthetic Chapter 10 file generator, and John kind of took over that part of the project, and we were able to create, I think, close to 3,000 unique Chapter 10 files describing, different flight tests, different flight patterns, and changing the various variables there. So, so those were the packages that were developed. Just to give you a feel for what it looked like, here are some screenshots of the interface. In the first one, we have a routine that says, okay, find me all files flight tests corresponding to tail number so-and-so. The tail number is the unique identifier of the aircraft. So this tells us that there were 4 flight tests run by this particular aircraft. More complex query: find all flights where the altitude is greater than 5,000 feet and the speed is greater than or equal to 320 knots. So that would tell us, do a search throughout the repository, and in this case discovered that there were 1,804 flights that met those criteria. Another example, Alexander created a little routine that would take the latitude and longitude of the takeoff, the latitude and longitude of the landing, and do a little GIS magic to figure out what the airport was where the flight took off and where it landed. This is the kind of summary. So as I said, when the Chapter 10 file would come into the repository, the converter would do a scan of that file, would figure out things like what the aircraft ID was, what type of aircraft, maximum latitude, longitude, maximum pitch, roll, and minimum of each of those, and so forth. So that was a kind of metadata collection part. And final thing I'll look at is this sort of a quick view graph. One of the nice things that we all know about Python is that it allows us, it has a lot of wonderful sort of plugins, for example, for doing graphics on data. And so Alexander put together some graphics that would show how you could do some quick analysis. So that's what we created. If you're interested in test driving it, it's still available on Keto Lab, and I encourage you to maybe sign up for Keto Lab. You can log in and go to the directory /FIREfly, and then kind of drill down, and you'll see several examples there. And you can also play around with the interface, maybe do some of your own queries and analysis if you like. So kind of get a feel for it. Next steps. We would like to take FIREfly to the next stage. As I mentioned, Cato decided not to do any more phase 2 projects after this one. And so we want to wait till all this COVID craziness is over and go back to the aerospace industry, go back to the Air Force and others, and see if we can take this prototype and build something, you know, more robust and more fully functional, and that will support test data. But we also think that this applies to, you know, not just flight test data. We really built it with the idea in mind that these capabilities could be applied to other kinds of data, other kinds of formats, and other domains. What we'd like you to do, if you're interested, anybody out there in Hug Land, please talk to us. Send us an email, chat, or whatever, and let us know. And we'd love to talk to you and give you more details and learn about your ideas. And also have a look, try it out on Kita Lab. So that's my kind of lightning version of the FIREfly project.
Thank you. Thank you so much for exciting use case. Any quick questions? There were a few questions in the chat that already were answered by Alexander.
Oh, okay. Great, thanks.
So one question that came in just now is, where can FIREfly experiment examples be found in Kita Lab? I think.
Okay, so you go into Kita Lab, and so you have to go to the website to sign up for Kita Lab, and that's can be a bit of an adventure, but it can be done, and we'd be glad to help you if you have any trouble doing.
Can you send this link in the chat?
Absolutely, absolutely. I'll do that.
And what kind of object storage is used? AWS or Azure in this case?
John, do you want to respond to that?
Oh, okay. I think Alexander already mentioned it.
Oh, Alexander. Okay, great.
Yes.